is 8th question. F of x is equal to mod x by x if x is not equal to 0. This implies that the x is greater than 0, it is the same. Less than 0, it is the same. Okay, right hand limit, left hand limit, both exist in one function. Okay, there are no separate limits given for right hand limit or left hand limit. A single expression for a single function for right hand and left hand limit. Okay, and at point 0 it will be 0. Okay, we can solve this function. We know that function is plus x where x is greater than 0 minus x where x is less than 0. Okay, so wherever x is greater than or equal to 0, it is plus x, and x is minus x when x is less than 0. Okay, so we'll substitute here modulus x only. Okay, for mod x. Next, f of x is equal to mod x. So mod x is positive x. So sorry, here it is mod x. Okay, mod x, positive x. X is not equal to 0, right? So it implies that greater than equal, greater than and lesser than. So here when it is greater, plus x by x if x is greater than 0. Okay, that is plus 1. I'll just write here one more, the simplified one. Plus 1 if x is greater than 0. Next is minus x by x if x is less than 0. That is minus 1 if x is less than 0. And 0 if x is equal to 0. At 0 it is, at the point 0 the function is also 0. Okay, now let's see case 3 cases we'll see here also. Okay, first is case 1. For all x greater than 0, f of x is equal to plus 1. So it is a constant function. It is a constant function. Therefore, f of x is continuous. F of x is continuous for all x greater than 0. Okay. And case 2 is for all x less than 0. Okay. Continuous at all point such that x is greater than 0. Okay. And x is greater than 0, sorry. For all x less than 0, function here is minus 1. It is also a constant function. Okay, it is also constant function. Therefore, function is continuous for all value where x is less than 0. And the case 3 is for all or at x is equal to 0. At x is equal to 0. Okay, at x is equal to 0, the function is 0. Okay, so here we have to check for 3 cases because it is at a particular point, right? At a particular point, we have to check right hand limit, left hand limit, and at that point. So function at that point is 0. Next is left hand limit. Limit x tending to 0 from left hand side, that is less than 0. Less than 0, the function here is minus 1. Minus 1. So, and right hand limit. Limit x tending to 0 from the right hand side is plus 1. We can clearly see left hand limit is not equal to right hand limit. Therefore, the function does not exist at x is equal to 0. Therefore, function is discontinuous only at the point of x. Discontinuous at x is equal to 0. Therefore, from case 1, case 2 and case 3, we can conclude that the function f of x is continuous everywhere. Okay, everywhere except at x is equal to 0. Okay, whenever x value is greater than 0, it is continuous. Less than 0 also it is continuous, but at exactly at the point of 0 it is discontinuous. So the function is continuous everywhere except at the point of 0. Okay. And question, f of x is equal to x plus 1 if x greater than or equal to 1, x square plus 1 if x is less than 1. So the same three cases will take. Case 1 is for all x greater than 1. Function is x plus 1. Okay. So x plus 1. It is a polynomial function. Polynomial function we can say. Okay. Polynomial function. So therefore f of x is continuous. Okay. F of x is continuous for all x greater than 1. That is from 1 to plus infinity. That is continuous from 1 to infinity. Okay. And next is case 2. Case 2 for all. Case 2 for all x less than 1. The function is x square plus 1. We can see this x square plus 1. It is a polynomial function. Polynomial function, right? So, therefore, it is function f of x is continuous. Continuous for all x less than 1. That is from minus infinity to 1 it is continuous. Okay. So, and also in the case 3 we have to check at x is equal to 1. At the point of 1 the function is x plus 1. Okay. And here at the point of 1 the function is 1 plus 1 is 2. And left hand limit x tending to 1 from the left side, that is less than 1, that is x square plus 1. So it is 1 square plus 1 is 2. Okay. Right hand limit x tending to 1 from the right hand side, the function is x plus 1. 1 plus 1 is 2. We can clearly see that right hand limit is equal to left hand limit. The function exists. Okay. And it is well defined. And next also right hand limit is equal to left hand limit, which is equal to f of 1, or we can write limit x tending to 1. F of x is equal to f of 1. Okay. So therefore f of x is continuous at x is equal to 1. Okay. So we can conclude from case 1, case 2 and case 3 that function f of x is continuous at everywhere, at every point or everywhere. There's no discontinuity for this function. Okay, it is continuous everywhere. Thank you.